here. So this is my data set. Right, my Alliance Bank of Malaysia Berhad, the stock price, then my risk rate, then the three variables here. Then I create my dependent variables. So okay, I create my dependent variables. So this one, Alliance Bank Malaysia, and then minus the risk rate. So I need to generate my what we say the return first, right? Yeah, return first. Then after that, I create my dependent variables. So these are dependent variables. So what next? After that, I need to always say I start from 990 month 7, then up to this data set I downloaded from the always say I'm not sure the source. I think the major one is this Yahoo Finance. So you try and then later on Yahoo Finance how to get the data set. So 2020 month 12. Okay. So this is my sample period. So I want to this is written. Okay. This is written. So I want to put this data set inside my e-bills. So I just copy, right? Yeah, copy from to 2020 month 12. Okay, copy this data set. Then I go to my e-bills. Okay, e-bills here. I go to create new work files. Then I use the dated. Okay, it's a dated data. Then I use monthly basis. So the start date is what date is it? Forget already. So fast. 1990 month 7. 1990 month 7. Then up to what year is it? 2020 month 12, right? 2020 month 12. 2020 month 12 with the 366 observation. 2020 month 12 with a 366 observation. Okay. So this is my sample, 366 observation. Then I need to paste, right? Yeah, MD group edit series. Then after that, I paste my data set inside here. So what I need to do now is I want to replicate. Oh, I have a serious one here. 0.77 is let me see. Oh, it's because the e-bills not recognize this kind of symbol. Okay, so this one is I use the market factors. Okay, I use the MF to represent this one market factors. So I rename it as market factors. So okay. Oops, sorry. What I did. Oh. What happened? How is it? So market factors, I make it properly first. Yeah? Okay, so I put it inside my e-bills. Okay, so I have all my variables here. So this is my buy, and then my three factors NF, SMB, and HML. So this refer to these three factors, right? The three factors here. Let me see. Yeah, market factors, the size factors, and also the value factors. So what I need to do now is I want to estimate, right? So I try to estimate my equation. So my first variable is my y, then followed by my constant, then followed by my market factors, and then my factors, which is SMB, and also the HML. Now I try to estimate this equation. So method here, right? So I will start with the least square method, the linear method, right? So this is my sample. I click OK. So this is my result. So this is my result, and yeah, this is just like a preliminary result, right? For my 365 observation. It's 366 because it is the return, right? So this is my market result. So that's the findings here. So as compared to this coefficient, right, 0.48, perhaps it's very small, right? Make it bigger. So okay, so my work found. So this is just a class activity, right? So I try to see whether the my three factors model. So I this my return for this alliance bank with the risk-free rate, and this my market factors, and this my SMB and HML, right? These two SMB is for the size and also for the value factors. So as usual, right, this is a linear equation. Then you can see my test statistic, right? So the constant value significance, right? Significance, and then another two factors are significant, but the HML is insignificant, right? HML is not significant. Then HML is referred to this one, the value risk. So the value risk is not significant for my case. And then the response for my this Alliance Malaysia Bank, this one, the response is actually for this, right, is higher as compared to the market factors, right? So this is can see like based on the size of this coefficient, the size, right, 0.048 is higher, right, as compared to bigger compared to this market factors. So that's why you can something like the diversification, right, when you do your portfolio. By the way, there is some limitation, right, as like this what we say, the return-based style analysis. There is a limitation here because again linear models. So you can see my adjusted R square here is quite low, right? Your adjusted R square here is quite low, it's 0.08. So it's just like the 8%, right? It's just like the 8%, 0.089 here. So like 8.9% the variation in this return for this alliance actually explained by these three factors, right? And then majority is explained by other factors. So this is the something like the R square values. This if I want to use the R square to explain my model, so this is the way, right? And what else information I can get from here is the test statistic, right? Significant, right? Yeah. So in the lecture 1 and as well as lecture 1, right, and lecture 2, we will talk about the testing. So this is an individual test. So to see the individual coefficient. So like just now I say HML is not significant, given us is lesser than the critical values. As well as this based on the critical values, right, like the test statistic, right? Key approach. Alternatively, you also can use this p-value approach, right, to justify, because this p-value is lesser than is greater than the significant level. Greater than the significant level, so it's insignificant. So HML is not significant in this case. So these are the three factors, right? So only these two significant at 1%, and HML is not significant at all in my case. Then I adjust the R square, it's just like R square, right? R square is just like 8.9%. The variation in the return is explained by my these three factors. Then what else information I can get from this E-views output is this F statistic. So this F statistic is highly significant at 1%. It means that at least one of the coefficient is not equal to 0. So there is a like standard explanation based on my F statistic. So what else information I can get from here is the AIC, SIC, as well as these criteria. These are the model selection criteria, right? So it's used together with the adjusted R square. If you have a different type of models, for example, You want to compare amongst the models. So these are the information criteria you can use to compare the model with the models. So let's say you have you want to use the different, you want to compare either is a 3-factor model is better or the 5 factors. So you can use this model selection criteria to compare. Let's say in your group project, right, you want to use these 5 factors. Let's say you want to put in another 2 more variables. Can you do like that? Can, right? Because if you don't want to construct yourself, the data is available in the Karma French, right? So once you choose your portfolio reasons, then you can add additional 2 more. So with the additional 2 more factors, so it's 5 factors. So if you want to compare 5 factors model with the 3 factors model, so you can use all these information criteria. It is called model selection criteria for you to select among these competing models, among these 2 competing models. So what are the rules? What is the rules here? The rules is higher the R-square, the better the models are. And also the lower RIC, SIC is better the model. So after you include additional 2 more independent variables here, so you can compare their model selection criteria to choose which model is the better model. So you can include that one in your group assignment, right? So this is the another direction for you to do it. So what else? Other things you can do if you want to do the model diagnostic check, you can go to view so like other tests like the diagnostic test, for example, the diagnostic for the residual, like to test whether the normal distribution residual is it follow the normal distribution. So you can use this Jacques-Barrat test. So for this Jacques-Barrat test, you can use. So for my case, the Jacques-Barrat statistic is significant. So the residual actually not follow the normal distribution. So this normally happen because I deal with the time series analysis, right? So the significance of this Jacques-Barrat is expected because of this time series analysis. Because I involve like 300 over observation. So the serial correlation actually is the distribution for this is normally will be validated, right? Normally will be validated. So because of this outlier issue, right? Differential point or the outlier issue, so will make my distribution for the residual no longer non-distributed. So what else we can do is other than that, you can just test like the serial correlation test. You also serial correlation test, right? So this the test to test whether your residual is it follow normal distribution or not. So given me the significance of this p-value, so the residual actually not follow the normal distribution, right? Also follow the assumption. Because when we do our revision, right, in our lecture 1, right, actually we will touch on the assumption, right? So these are the things that analysis test to diagnose. So later on when you do, I think next week we're going to introduce you the ARDL. We also will go through all these analysis tests, touch anyway. So and then this is for this heteroscedasticity test. So for this test, I do this white test, for example, to check for heteroscedasticity. So I click OK. So based on this observation kind of R-square, the sensitivity is insignificant. So and my assumption of this variance actually are constant, like this, right? Based on this observation kind of R-square is constant. So what else you can test? Actually, you can look at the Ramsey reset test to test whether your model is it got specified or not. So when I test on it, actually my F statistic here, the Ramsey reset test is significant at 5%. So given me the significance of this Ramsey reset test, actually my model is misspecified. So you have to diagnose that actually the model is misspecified. Is it because of the overlook certain important variables like the 2 other factors that make my model misspecified, or because I use the different, or maybe I can say I use the incorrect functional form, also make my test statistic validated based because of this significance of this test statistic. So there are 2 reasons why my statistic is significant. Either is I overlook certain important variable, maybe because of the 2 other factors, right? Maybe because another reason is maybe because I use the inappropriate functional form, right? So these are the 2 reasons, right, to make my test fill in this condition. So I also can use this Q-sum test, yeah, like this Q-sum test in this one, yeah, recursive estimate or estimate. So I can use this QSUM or square or QSUM test to test the stability. Yeah, my model is not stable. My model is not stable. You still remember one of the slides we got mentioned that the regional culture and regional diversification, right? The culture as well as the region in the Malaysia case different compared to the US case, right? So we have to do something like this, maybe make my models is validated the assumption, like the Ramsey reset, etc. Because Malaysia case, right, the M-Bank, right, Alliance, right, I use Alliance. So Malaysian case is affected by the Asian financial crisis, right? So that's why you can see there is a statistic here is actually it's out of this critical value. It's not stable. It's not stable during this particular period. It's especially after this Asian financial crisis. So that's why these cultures or the regional factors might make my models not stable in this case. So this is the proof, like, already proof one of the statement we discussed in one of the slide. Because I'm using the three factors that actually linked to the US case, right? But my fund actually my portfolio is Alliance, so Malaysia case. So that's why the model is not cannot explain well. Even though there are two independent variables that can drive my return for my Alliance, but actually the diagnostic test shows that actually not that appropriate. So I need to modify again my models. So that's my that's something like what we can discuss like from this assignment. So okay, it's time for you to do your exercise. So it's time for you to help me to figure out how to gather data from this Yahoo Finance. I gathered data I think the 1 or 2 years ago is available. I'm not sure the platform because all these things change every day. So you can try to figure out. Then if by the way, you also can try to use my data set, right? My top group data or the data set for this bank. You can try to replicate the three factors model. Or you can try to, because I see someone already use like the Pfizer's or right to use the top growth or the data in this year. So you can try to figure out here the Yahoo Finance or your favorite data set. Okay, you can try. So I think that's all only for our today lecture. So next week we're going to discuss about the spurious equation. Okay, discuss about the spurious equation. So by the way, please go through all the journal articles I shared online, right? I shared online. And also what we discussed in the class is just like theory, right? For the more application side, you can try to look the key papers and then the journal articles I shared. Like for example, like more on the application side one, right? More on the application side one. So you can try to go through like the application side paper. Like for example, like this recent paper, like this published in this North American journal, and also this Jack Brown and Jackman 2010. So these are the two papers that is for application side. You also can try to search the journal article online. This first, right? Just like three factor, just like right? Three factor model, for example. Three factors model. Yeah. Like in Malaysia, for example. Oh, this one is published in this ResearchGate, right? If the type available, then you can download that. So this one is in the Bursa, Malaysia. They use this for the Malaysian manufacturing industry, right? So this is Malaysian case, this Malaysian case. So for example, they use the 325 company, and then they have this SMB, ML, and then they found the market factors. Yeah, so now you know what is market factors, right? The risk rate, market minus the risk rate. So here a PE rules that means in their model they find highly significant. Then also further support the existence of value and capture variation in the stock. And then the size effect, yeah, size effect means that the HMR and also the RMB, the SMB, right? The SMB, yeah. The SMB somewhat is mixed up because they're doing is for the 325 companies, right? So I'm not sure, I don't go through the paper line by line yet, right? You can download the full paper, then go through it, then they compare. Yeah, they compare based on the adjusted R-square. So they found out that the adjusted R-square, right? So they compare three factors model with the CIPM models. So as you know, CIPM model just the market factors only. So they can say they found out that the three factors with the additional two more factors actually is better than the CIPM. So they use the adjusted R-square. Just now I used the example is compare the three factors with the five factors, right? So this paper, they compare the three factors with the CIPM. So, and then their adjusted R-square is 62% with the three factors. But for the CIPM, just 32%. So it means that the adjusted R-square is 0.62. And then this one is 0.32 for the with the CIPM model. So it's better. So it's explained the variation in the Y is explained by estimated model around 62%. So it's better than the CIPM just with the 32%. So this is how they apply in the case for this Bursa Malaysia. Then how about maybe in other countries like in Thailand, you can try to take a look at Thailand. So you have a different set of the Thailand also good, right? Pharma French three factors in the Thailand case. So you can try to go ahead with all these papers, right? And this is a Pharma French three factor. But this is something I say is not published paper lah, because it's just like the just like what we say, just like the working papers, right? If you want to go through the published paper, you need to go through this, what we say, the journal, Scopus, Science Direct, etc. Right? So it's you can go through that, but technology. So you can see how they come up with their models, right? Yeah. This is the original CIPM models, and then this is the three factors models, right? Three factors models with the respective slope coefficient. And this is something like your discussed in the CIPM, like what we said in the Pharma French, right? And how they construct the SNV and also HNL. Okay, so they use the Pharma portfolio in the 5 Asian Pacific. Yeah, the data is get from this data library. Yeah. So actually they construct the data similar like the Pharma French data. So this is how they come up with the research paper, right? Yeah, exploratory research. So then what they run. So this is a sample. They're running for 1, 2, 3, 4, 5 countries, right? 5 countries. They use the 5 countries, risk-free rate. Yeah, risk-free rate. So and then the report. What you can report, right? You can report their when just now we got a return, right? You got HNL, SNV, and also one of the market factors. You can report their respective discrete statistic, right? So these like the exploratory study like before you do the analysis, right? You can study about their mean. So actually, what you can do here, right? Before you do analysis, you can draw, right? You can open and then as a group. Then you can go to see their statistic, right? Common sample. So their mean, median, maximum for each statistic is you can describe them. Right? You can describe their statistic. You also can draw their graph, right? You can also draw their graph. You can go to the multiple graph here, right? To draw their graph. So respective graph. So you can have the high to low and then your dependent variable and also the market factors as well as the risk-free rate. You see the risk-free rate is going down, but it's suddenly up here, right? Because of this event, right? So you can export, you can export the graph, right? In your result, in your tables. You can report the result in the table, something like this. So report it, right? So you can do it for your group assignment, something like that, right? Okay. So what else they report? You also can report for this explain, right? Regression, that regress, like what you did just now, the regress for the China case. So I have two only, book to market, and then science, and also intersect, right? And also the beta. I'm not sure what is the beta for, right? So I think it's the three factors here. Yeah, I think the three factors that just report with the different country. And then intersect based on different country, they report that intersect. They explain the beta. Oh, the beta is for the constant. Okay, here got constant. Then what is this? Beta. So if you have time, right, intersect is constant now. If you have time, then you go through like what is the beta here, right? Intersect. So this is the thing, this is the thing that I study also. Okay. So that's all only for today. So perhaps go through all the journal article I shared. Then you go ahead with this analysis. Then you see whether you can replicate the result. Okay. So see you all next week.